So now let's talk about how to name alkanes that have substituents on them. And what substituents means that it's no longer a linear chain of carbons, but sometimes a branching of things will come off, either a branch of another carbon or some other atoms. Okay? So for example here, if I were to name this alkane, I would call this a 1, 2, 3, 4. I would call this a butane, right? What about this one? What would I call this one? 1, 2, 3, 4, 5. I can't call this a pentane because it's not a long chain before, because a pentane would have this carbon here connected to this carbon, not to this middle carbon here. And I can't call this a butane because this is already a butane. So neither a butane nor a pentane. So it turns out this is what we call a substituent. Okay? Anything that hangs out, branching off of the main chain, is the main chain, which is the longest chain, is called the substituent. So before we go on to naming this compound, let's take a look at some common substituents that you are going to be responsible for. The first one, if it's just a branching off that has only one carbon and some hydrogens, we're going to call that, based on something that has only one carbon, it's called methane, right? So instead of calling that a methane, we call that a meth, because that's a root word, and ending that with IL. So this is called methyl. Whereas this one is an ethane, so we call this a ethyl. How about 3? 3 carbons is propane, so this is called propyl. This one, how many carbons? 1, 2, 3. It's also 3 carbons, so we can't call this propyl because then we'll confuse it with this one. Since it is like propyl, we're going to then call it something that's like, the word is iso. Isopropyl. Okay? You might have heard this before, like in, for example, rubbing alcohol. That's called isopropanol. Okay, so that's because of that. And then the last type of substitution you are responsible for are halogens. When instead of carbons hanging out, you have fluorine, chlorine hanging out. Okay, so when, for example, fluorine is coming out, that substitution is called fluoro. Right, so fluoro. And if it's a chlorine that's hanging out, we call that chloro, right? Just ending the INE at the end to an O. What about bromine? That's bromo. Iodine, that's iodo. Okay, so those are the substituents that you are held responsible for. Okay. Let's erase that to clear some space. So here's the guideline to naming alkanes. If you follow these guidelines, naming system becomes very systematic. Right? The first one is to find your longest chain. Right? Longest chain means that it is the most continuous. It's the longest chain that is continuous. Meaning, if you have to connect them in a single line, you don't have to lift up your pencil. Okay? So for example, here, what's the longest chain here? 1, 2, 3, 4. Right? If you were only to travel through the bonds, that's your longest continuous chain. You can't say 1, 2, 3, 4, 5 because there's no connection here, right? And if you want to say 1, 2, 3, 4 and go back 5, no, you can't do that. It has to be continuously connected. It can't be like one bond and another bond. So the longest chain here would be 1, 2, 3, 4 or 1, 2, 3, 4. Doesn't matter, it turns out. You can convince yourself later on it doesn't matter which side you count it on. So that's your longest chain. The next thing you want to do is you want to start numbering your chain. Right? You want to number from the side that will meet a substituent first. So I could have numbered this being my carbon number 1, my carbon number 2, my carbon number 3, and my carbon number 4. So if I start from the left-hand side, the first substituent that I see is on carbon number 3. But the guidelines for number 2 here is trying to tell me is I have to start on the side that will see a substituent first. So if I start from the right-hand side, this is my first carbon, my second carbon, my third, and my fourth. When do I see a substituent from the right-hand side? I see it at number 2. Versus, if you go from the left-hand side, it's at number 3. Right? So which side wins? From the right-hand side then, because you see it as number 2. So then you would number it from the right-hand side. Okay? Let's take a look at number 3 here. Now you're going to write the name of the alkane, putting in the substituents in an alphabetical order. Okay? And you're going to put also in a locant for it. every substituent must have a locant. A locant is basically the address. For example here, the locant for this methyl group is 2 because it's hanging off of the second carbon. Okay. Some more rules here. You want to put a dash between any number and any alphabet letter. Okay. Another rule here then is if you have two numbers, you want to put commas between them. Okay, so let's do this one. What is our longest chain again? It's 4. What's the name of a 4? 4 is butane. Right? And now our substituents are methyl group. Since there's only one substituent, I don't have to do alphabetizing. There's only one methyl here. So I say that the locant first is 2 methyl. So what do I need between 2 and the methyl? I need a dash, right? Because this is a number and this is an alphabet letter. So 2 methyl, and I don't need any space or anything in between. So it's called 2-methyl butane. It's the full name of this compound. Let's do some more examples. Okay, this is our molecule here in its full length structure. What is the longest chain? Number 1, what is the longest chain? 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, right? So those are my 3 possible chains I can count. Obviously 5 is the highest, so I'm going to count this as my longest chain. Number 2, numbering the chain. Okay, so do I number it from the left or from the right? 1, 2, ooh, I see a substituent, chlorine. 1, 2, 3, oh, methyl is all the way at number 3, so I'm going to label it from the left-hand side this time. So that's number 1, 2, 3, 4, 5. I'm going to start saying that circling my substituent with a locant number 2 for chloro group, locant number 3 for the methyl group. Okay? In this case, I have 2 substituents, so I have to alphabetize them. Chloro, it starts with a C. Methyl starts with an M. So which one goes first? The chloro goes first, right? So this will be 2, the locant, chloro, and then 3, right, the locant for methyl. What do I need between 3 and chloro? A dash, right, because it's a number and a letter. Methyl. Can I just write methyl like that? What do I need in between? Another dash. Okay. 3 methyl, and then finally that's all my substituent. Now I just put in my main chain, which is 5 pentane. Okay, so let's do some more examples. Alright, before we go on, before we name this compound, let's do a checkpoint. How many carbon atoms are in the following condensed structure, and how many hydrogens, if you want a second question? Let's do the carbons first. Okay, so from this structure, you know that at every line segment there is 1 carbon, right? So 1, 2, 3, 4, 5, 6, 7. That's 7 carbons. Don't count this as 8 because this line segment is connecting with the chlorine, not with just emptiness. If it's just emptiness, then that means there's a carbon there, but if there's an atom there, that means it's connected with that atom. So the answer is C7. How many hydrogens? Well, this carbon has how many hydrogens attached to it? It has only 1 bond, so it must have 3 more hydrogens. How about this carbon? It has only 1, 2 bonds, so it must have 2 more hydrogens. How about this guy? 2 more. How about this guy? This carbon is connected to 1, 2, 3 other carbons, so it must have only 1 hydrogen left. Okay? So let's count of 3, 2, 2, 1, 3, 1, 2, 3. So this only has 1. This is also only 3. Okay, so that's 3 to 3 is 9, 10, 14 hydrogens. Alright, lastly, let's name this compound. What's my longest chain? My longest chain is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Among those 3, which one wins? 6. Okay, good. Number 2, number the chain. So if this is my longest chain, I'm going to number it 1, 2, 3, 4. Oh, that's the substituent. How about this side? 1, 2. 2 is better. So I'm going to start from the right hand side. 1, 2, 3, 4, 5, 6. Now let's take a look at my substituents. I have a chloro and a bromo. I have a chloro and a methyl. So this is going to be what? Chloro first, then methyl. So this is 2 dash chloro dash 3 dash methyl. What's my longest chain? 6. So hexane. Okay, we will see another example where we see more of the rules being applied. Okay, so in this one, what is your longest chain? 1, 2, 3, 4, 5. 1, 2, 3. Nope. 1, 2, 3, 4, 5. That 5 and this 5 actually is the same, because if you notice that if these two switch, they're actually the same thing, right? CH2 and CH3. So we're not going to worry about that. So it turns out the longest chain is 5. And also, if you count from the left or from the right, it's going to be the same, because 1, 2, 1, 2, both of them you see are methyl groups, so it doesn't matter which side you name it in this case. So this is 1, 2, 3, 4, 5. If you did it from the opposite side, convince yourself that you're going to get the same name. Okay, so let's talk about substituents. You have a substituent here at number 2 and number 4. They are both methyl groups. So when they have the same substituent, you don't have to say methyl twice, or 3 times or 4 times. You just say a prefix in front of that. If it's 2, di. If it's 3, tri. If it's 4, tetra. Okay, so for example here we say that the locant here is 2 and 4. Remember I said for every substituent. So I must say that there's a methyl group at number 2 and a methyl group at number 4. Remember what do I do when there are 2 numbers next to each other? I put a comma. So 2, 4, dash, dimethyl. Okay, the di is a little redundant, but it's okay. The dimethyl says that I have 2 methyl. The locant tells me that the first one is at number 2, the second one is at number 4. Okay? And then lastly, put in the whole name there is a pentane. Okay, so how about drawing a compound from the name? From the name, you should start out with the parent chain, right? Because that's what you're going to draw as your foundation, and you're going to branch off things from it. So in this case, our parent chain is butane, it's an ending. So that means it has to have how many carbons? 4. So I'm going to do the skeletal structure here. 1, 2, 3, 4, right? 1, 2, 3, 4 carbons. At position number 3, and it doesn't matter which side you label it on, the numbering, 1, 2, 3, 4 or 1, 2, 3, 4, because when you're drawing it, you are just translating it. Okay, so I'm always, the easiest is to start from the left. This is 1, 2, 3, 4 for me. So at the 3rd position, there's a bromo group. So 1, 2, 3 is a bromo group. And at number 1, there's a chloro group. I spelled chloro wrong, but that's okay. So I can put chloro there. Now let's double check if the name was named, if this molecule was named properly. If I were to name this molecule without giving that name already, I would say to myself that it is a butane. That's correct. So 1, 2, 3, 4, and I would name 1 here because if I name number 1, the first substituent is at number 1 position. If I start from here, 1, 2, the first substituent is at number 2 position. So this side wins. And then what about naming bromo before chloro though? Even though this is 1, it doesn't go in the front. It is because we're doing alphabetizing, right? So B comes before C. So even though this is 3 and this is 1, 3 comes first because of this B. 3 bromo, 1 chlorobutane. Alright, so our final checkpoint here is what is the IUPAC name for the following alkane? Alright, step number 1. Longest chain. What's my longest chain? 1, 2, 3, 4, 5, 6, 7 versus 1, 2, 3, 4, 5 versus 1, 2, 3, 4, 5, so 7. And then which side do I want to number it from? The left-hand side or the right-hand side? You want to do it from the right-hand side. So this is 1, 2, 3, 4, 5, 6, 7 because you see it as substituent number 2. Our first one is bromo, whereas if you see it from here, it's 1, 2, 3, 4 before you see this methyl group. Right? So now we have to alphabetize in substituents. Bromo versus methyl, which one wins? First is bromo, so we say the locant for bromo is 2 bromo 4 methyl, 7 is heptane. Okay, so that's our answer. Now I'm going to change this molecule just a bit and see, so that we can see another rule that may come at play here. Let's say that this is a fluorine instead, and this is another CH3. Okay, both of them are connected to this fourth carbon. The longest chain hasn't changed. It is still 7, and it's still numbering from the right-hand side. So this is still 4, and we have an extra methyl group here. So again, which one comes? Which substituent comes first in our naming system? The fluoro group or the methyl group? Okay, you don't consider this being a dimethyl group and consider di coming before fluoro, D coming before F. You consider the root one, so it's the fluoro coming before the methyl, right? We say 2-fluoro. We have 2 methyls here. Remember that we have to have a locant for every substituent, so just because we have the same number in a substituent doesn't mean we only write 4. We have to write 4, 4. And since there's 2 there, we say dimethyl, and this is again a heptane. Okay, again, I want to emphasize 2 things here. First is that the locant number, you have to write it for every substituent. Even though it's just 2 methyl groups and they're both on number 4, you have to write 4, 4. The di here means that there's 2 of them. The 4, 4 means here the first one is on number 4, the second one is also on number 4. You can't just omit one of them. The second thing I want to emphasize here is the alphabetizing here. You want to emphasize the F before the methyl, right? You consider the root substituent, which is fluoro versus methyl, not the D. You don't consider D or as in the di or the tri or etc., one of those prefixes when you alphabetize. You can have many more examples. You want to try it out and name them. It should be fun and it should give you good practice.